can see the tears in the email after the midterm. It was 8 a.m. was too early for me, so I just decided to skip the last month of class and read the book. The exam wasn't very close to the textbook. So where in the textbook is the SJS inverse?
Nowhere.
It is not. So good thing you came to lecture. And where do you read about it? Yes, in that handout I gave on the first day, the field guide to diagonalization, which is also available on your textbook. Yes, very good. Under class handouts. So I've got a transition matrix. And let's write it this way. So I've got a population of x's and y's. And this year's x, y's are at whatever they are. And then this transition matrix times that population will give me next year's. Yes. Oh, we are. I had a long-winded way to label your handout. So, well, we're going to start with a certain number of people. I'm not telling you very much. I'm just telling you that we've got this starting population. And we end up with, we don't know. So, who knows how many people we have. And then, we're going to go 1 million years in the future. And then we're going to end up with some number of A's, some number of B's. And I'm going to tell you a few things. For this transition matrix, it's got two eigenvalues. Lambda equals 1.2 and lambda equals 0.8. And their corresponding eigenvectors, which you can work out, are 1.2 and 0.8.
Should that be given, or we're going to find it?
Expect to do both. Okay, so what we can do is we can write that original population as some number of 2 1s plus some number of 5 3s. And then 1 million years in the future is this 2 1, whatever number we have there, is going to get multiplied by 1.2 times to the 1 million. And this one will be 0.8 to the 1 million. And what's 0.8 to the 1 million? Is 0. So essentially, this says that the ending population is going to be some multiple of 2 1. And what do you know about the ending population? What's the size? So I know A plus B is 3,000. And so the ratio of the A's to the B's is for every B, there's 2 A's. Or 2 A's for every B. So can you think of
3,000.
So we would solve this problem not looking at the entire thing, just by knowing that they split 3,000.
Yeah. And you notice that I had one condition on this. B naught is not equal to 3/5 of A naught. Why did I include that? So what would happen if 5 B naughts not just titers. So if that happened, then when you broke down the initial population in terms of the eigenbasis, it would be 0 of these and a certain number of those. So if the initial population started in the 5:3 ratio, then it would just be, the initial population would be a multiple of this eigenvector, and it would go to 0. So as long as that initial population is not entirely 5/3s, this is the dominant eigenvalue, and that's its corresponding eigenvector.
Also, saying that the final population comes out in the ratio of 2 to 1 is a pretty big approximation, right? Because it's actually 1.2 raised to the million, not 1. Is that right?
Okay, so the latter is, so say the former again?
We said the final population will be about 2 to 1,
Yes.
but it's actually, that's all scaled by whatever 1.2 to the million is,
Oh, right, but remember, so our AB is 1.2 to the 1 million times some scale,
Yeah.
times 2 ones. So I just said this is going to be a scalar for us,
Okay.
and we need that scalar to turn into.
Oh. Yeah.
Right. So basically that 1.2 to the 1 million is taken care of with the scalar.
Okay.
So we started with a microscopic number of A's and B's.
So how do we know for certain that the scalar is 1,000? Can there be any other combination?
No. So there's no way to be in a ratio of 2 to 1 with a total number of people, 3,000.
Okay.
So what we have is we have twice as many, the number of A's is double the number of B's. So we also get that A is 2B. So this is essentially 2 equations and it only has one solution. Okay. So we've got an after party in about another hour. We're going to talk. But did you work out all of the sums?